Welcome to the 2020 Olympic Games.
On your mark, get set.
Wait! The social distance.
On your mark, get set.
Go!
And now for the 100-meter crab walk. Crab walkers, to your mark. Set. Go!
Okay.
Oh my goodness. New world record! And now for the 400-meter somersault race. Somersaulters, to your mark. Set. Go! Oh my!
Now from Kenya. Now from Switzerland.
And now from Cuba.
From North Korea. Hi, Rush, please.
From the United States of America, world record long jumper, Robert Nyson.
Let the e-learning begin. Happy Wednesday, everybody. And I just like to give a big thanks to 3 of the people in the video were our children, and the other 3 were friends and roommates of Noah's from Bethel. And you know, I just can't compete with that. A couple of them actually ran track at Bethel, and not only did they run track, they were like All-Americans in the NAIA. And one, in fact, was also All-State when he was back in high school for Northridge. And so All-State in track. You think I can compete with that? I can't compete with that. I'm telling you, those guys, they got more miles on their treadmill than I have on my car. And like, whew. And so, but rest assured, the only jogging we're going to do today is I'm going to be jogging your memory on some math ideas. And so make sure you take attendance on the form here and get that done right away. A couple of you are forgetting. You'll forget on a Friday or you'll forget on a Wednesday. And so get that done. It makes it a lot easier on me. once you get that done, we're ready to start the notes. Sore for geometry this morning. And so if we look down here on geometry, you're going to feel like today's hopefully an easier day. It's really what we've been doing lately after we left transformations is doing analytical geometry, geometry on the coordinate plane. And so we're mixing algebra with geometry, and since you had such a good algebra teacher last year, I heard, then you're going to feel like this is easy. And that's the same thing's true next year. You keep working hard now, next year you're going to be like, man, this seems easy at the high school. And so that's what we want. And so we want a good foundation. So we're going to just talk about the analytical geometry, talking about shapes, parallelograms, parallel sides, perpendicular diagonals on a rhombus, things like that, but looking at their slopes and things from an analytical perspective, from an algebraic perspective. And so our homework tonight is page 537, just problems 1 to 6, 11 to 20. I do have a handout for the graphs and for everything, so make sure you use that. That's attached to the notes. And so it'll be a huge benefit to you and save you a lot of time. And remember, when we're graphing lines, we use a straight edge. And so none of this freehand and stuff like you're writing with a mouse on teaching e-learning lessons. You want to use a straight edge, okay? And so if we take a look at today's lesson, this is notes number 123. And so this should be hopefully a quick review, and we'll get through this. If two lines are parallel, then their slopes are, Megan? Yes, the same, equal, whatever you want to write. The slopes are the same, the lines are parallel. If two lines are perpendicular, then what are their slopes? Vadim? Yes, they're opposite reciprocals. What's that, Grant? Well, yeah, except for vertical and horizontal lines, those aren't opposite reciprocals, and they're still perpendicular. So yeah, in math, you got to be careful how you say things. But if lines are perpendicular, if they're not vertical or horizontal, then their slopes are opposite reciprocals. Opposite, what's that? Multiplicative inverses. Yeah, but I ain't writing that with the mouse. I can barely get reciprocals out of this. And so reciprocals. Okay. So your homework tonight, a lot of it, hopefully, we want you to watch the whole video, but you'd be like, well, maybe I didn't need to. I'm going to move myself up here. But hopefully you do. And you should, just like sitting in class. You don't just walk out in the middle. You don't just raise your hand and say, may I be excused? My brain's full. That doesn't work. Might work at the dinner table, but it doesn't work in class. Your brain ain't full, so sit down. And so we're going to plot this point, -4, 1. And swim over to the ladder and go up 1. Then 2, 3, right? 2 up 3. I hope I don't goof this up. 4, 9, right? 4 up 9. 49ers, Gold Rush. And the minor 49er. And then S, -2, 7. Right there. Well, obviously, if you plot this, you can tell a lot of things. If I ask you, well, what shape is it? Well, partner, it looks like a parallelogram to me. Whoa. But how would we prove that? By looks? Do we ever prove things by looks? Remember that one trapezoid problem? If it looks like a duck and walks like a duck, it must be a duck. That thing was drawn way out of proportion. And so we graphed it. Done. And then analytical geometry, what are the slopes of these sides? So if this is P, we better label this, and Q, and then R, and then S, we went counterclockwise. Usually we go clockwise. I don't know what's up with that. And so what's the slope of PQ? Well, the slope is rise over run. Oh yeah, ringing a bell? And so if we rise 2, run 6, the slope of that is, what is that, Isaiah? 1/3. Very good. Well, if the slope of PQ is 1/3, what's the slope of RS? Well, it'd also be 1/3. Ooh, did we just prove that the slopes are the same? And therefore the lines are P-A-R-A-L-L-E-L, parallel. Now what's the slope of QR and PS? Well, the slope of this line is 1/3 and 1/3. The slope of this line is rise 6, run 2. Well, rise 6, run 2 is the same as rise 3, run 1. So that's a slope of 3. So these two lines have a slope of 3, not a length of 3, a slope of 3. M equals 3. m equals 3. Now, are these reciprocals? Yes. So does that mean they're perpendicular? No, they have to be opposite reciprocals. Do these lines look like they make a 90-degree angle to you? No. That's why they're opposite reciprocals. One's positive, the other one's negative. One's negative, the other one's positive. And so the slopes of the sides are not opposite reciprocals. But it says, show the slopes, use slopes to show the diagonals are perpendicular. Well, where are the diagonals? Can you come up here, Camden, and draw them in? Okay, take that. Remember, going up, the little finger puppet, you know, all those things. The ends of my fingers don't hurt anymore. And so that diagonal right there, and that diagonal right there. Now, Taryn, what are the slopes of those diagonals? Well, the slope of PR is what? Taryn? 1. Oh, you're tearing it up. Good job. And then what's the slope of QS? Sidel Dene? Yes, -1. Good job. And so notice those lines are opposite reciprocals because 1 times -1 is -1. Now we'll see who knows. What kind of quadrilateral is PQRS? It is a what? Christopher? Yes, it is a rhombus. Now, how do we know it was a rhombus? Well, it has opposite sides parallel. Opposite sides parallel. That's true. Well, it has the opposite sides congruent. But did we show that the opposite sides were congruent? No. So that's not the definition of rhombus that we want. It is a parallelogram that has what? Diagonals. That's supposed to be a D. Diagonals that are perpendicular. And if we were back in the room, Morgan would pull out the geometry book and she'd say, Mr. Nyson, that is theorem what dash what? That the diagonals of a rhombus are perpendicular. And so she'd be reading that. Oh, the memories. Thanks for the memories. I'm going to shed a tear. All those great memories. And so we're making more memories. And so don't get too sad. Otherwise, I might have to get a tissue. And so we have that. Okay? And so let's take a look at this next one. It says, plot this one. W is at 1, 1. X is at -1, 3. Y is at -4, 0. I sure hope I don't goof this up. And Z is right here. And so we're going to connect these. Get your straight edge out on your homework. Don't be freehanding them. Whoa. Whoa there, partner. And so we're going to graph these. This is better than graphing them on the board back in class. Well, what type of shape, obviously, we have? We have a rectangle. But if you just jump down to the end, you're like, well, why is it a rectangle? Well, it has opposite sides parallel. Why do you know that? Oh, well, it looks it. And so, while train tracks are parallel, but they don't look it, it looks like they're going to meet. We're going to crash at the end of the road. And so, I wouldn't be going by looks. But why is it? Well, we graphed it. And what's the slope of these lines? Well, the slope of these lines are going to be what, Carissa? Well, these are -1. That's very good. And then the slope of the other lines, Carissa, those are +1. We can just count. Rise over run. Rise 3, run 3. Rise 3, run 3. And we could graph this. What was this? 1, 1. This was W, X, Y, and Z. And then it says where the slopes, all that stuff. So WX was, those were -1. These were 1. Why are they perpendicular? Because they're opposite reciprocals. What type of quadrilateral is it? It has 4 right angles, a rectangle. And so the lines are perpendicular. Perpendicular lines form 90-degree angles. And a parallelogram where the sides are perpendicular. See, in the last problem, the diagonals were perpendicular, the sides weren't. And that's why it's a rectangle. Okay? And let's take a look at the third one. We're just moving right along. Moving right along. Maybe Kermit can sing that one. And so we got A is 3, 4. Right 3 up 4. B is 0, 1. and C is 4, -3. Well, guess what? 3 points make a triangle. I ain't doing this problem. You know, what shape does it make? Triangle. Duh. 3 points, 3 sides. Oh, but the question's going to ask, what type of triangle? Oh, I see. So let's graph it. Well, we could use the distance, using the Pythagorean theorem, find the length of all these sides and prove that scaling. But see, we're not focused on that today. We're just focused on slopes. And so we graphed ABC. A, B, C, D. And we're right there. And then it says, what's the slope of AB? Well, if you rise 3, run 3, what's that going to be, Aiden? Yeah, it's going to be a slope of 1. What's the slope of BC? What's that going to be? Carson? Drop 4, down 4? Yes. And that's going to be -1. So that slope's -1. Well, what's true about those? We got a +1, we got -1. And what kind of triangle it is? Oh, it's a right. You're so right, Charlie. And what would that, how do we know? Because these two sides are perpendicular. Great job, Charlie. Now, Sarah, what's the slope of AC? 1, down 7. So the slope of AC is going to be down 7, right 1. So that's going to be -7. Very good, Sarah. So if the slope of AC is -7, what is the slope of the altitude to it? Well, remember way back when we found where's the height to that one? Well, it would be right about here, because if you visualize, well, no, that's not drawn very good. It has to be perpendicular. Let me turn my head. I could get my mouse. It'd be like that to form a right angle. Well, are you going to count that? Are you going to figure out how many you rise and how many you run? No. Then how in the world are we going to know the slope of the altitude to that line, which is -7? What would we get, Avery? -1/7? Does it look like this line is going downhill? Oh, yeah. Avery, yeah, you knew it. And so it's +1/7 because these have to be opposite reciprocals, multiplicative inverses. Okay? And so it's -7 and then +1/7. Okay? Now, we want to take time and we want to start our homework. Okay? So get out a piece of paper, piece of pencil, and a piece of paper, and so we'll get started. Homework, it says find the slope of AB. Then it says find the slope of any line parallel to AB. And then it says find the slope of any line perpendicular to AB. So remember, how do you find the slope given 2 points? Well, we could draw a picture. Sure is nice when we have the pictures. But Tim, are you out there? Tim, I had to hear from you. And so it's slope equals, what's the formula, Tim? Yes, it's y2 minus y1, y1, over x2 minus x1. Remember that? The difference in the y's over the difference of the x's, it's rise over run. So on top, you're going to do 4 minus 0 and get 4. On the bottom, you're going to do 4 minus -2 and get 6. 4, 6 equals 2/3. That's the slope of the line. The slope of any line parallel to it would be the same. You could write part A and B together. And then part C would be the opposite reciprocal. And then same thing for problem 2. For problem 3, you use this picture. And just write slope of OE. Well, that's 7/2. Rise 7, run 2. And then this would be the slope the same. Remember, horizontal lines have what type of slope, Jack? 0. Yes, horizontal have 0. And just write those 4 things and get it. Problem 4, you're using this picture. And you're finding the slopes in the opposite reciprocals. Problems 5 and 6 are just like the ones on the notes. Then when we get to the last ones, 11 to 20, this is the analytical geometry. This is why we're doing this. We used to prove shapes by doing, 2-column proofs. Well, there are things called coordinate geometry proofs, where you're proving it by using your algebra and your analytical geometry. So you're going to graph this, and the first thing you're going to do is show the opposite sides are parallel. So you'll write on your paper, on the handout, you'll write slope of AB, M of AB equals, and you'll show that the sides that are parallel have the same slope, and you'll show that the other pair of sides have the same slope, and then opposite sides are parallel. You got to do that. You can just label your picture. And then B, it says show the opposite sides are congruent. Well, if you got 2 points, you can use the distance formula or just the Pythagorean theorem to figure out what the length of the hypotenuse is, and then show it on the paper. Show that length is the square root of whatever, and this length here is the square root of whatever, and this length here is the square root of whatever, and this length here is the square root of whatever. And the n plus people, they actually simplify their square roots. And then we give you an extra point. And some of you are noticing, man, I'm racking up some 11 out of 10s. Then I do a few logic problems. I'm in good shape. So 12 says it's going to be a rhombus, but show that the diagonals are perpendicular. Morgan, what's the theorem? Yeah, no theorem numbers, because other people have different geometry books. And you still have my book, but you will be returning it. Details to follow. But when they tell me, I'll let you know. And we'll get our mirrors back, our compasses back, and everything else back. Problem 13, you got to show that the diagonals are congruent. Know when to show it. Know when to walk away. Know when to run. Got to help your mama. Remember, Kermie knows that song. And then the last one, the old isosceles trapezoid. Well, to show that something's an isosceles trapezoid, you show that you got one set of parallel sides. You got to first show it's a trapezoid. And then it says, it gives you a hint, show that the diagonals are congruent, and write that down. So on 15 all the way down to 20, you're going to plot the points. And your proof is not, it looks like a duck, walks like a duck, it must be a duck. Your proof is showing opposite sides parallel. Diagonals are congruent. Diagonals are perpendicular. Various things, and you show it. Then on problem 19, it says you have a circle. Well, where's the center, Jerry? Yeah, 0, 0. And what's the radius? 5. So I have radius 5 of a circle that's centered at the origin. And then you got the point 3, -4, which is like down here. Well, what would the tangent line slope be? Oh, I gotta know. Oh, yeah. Yeah, Avery, what is that? Yes, the line tangent at a circle is always perpendicular to the radius at that point, at the point of tangent. So if you can find the slope of this, which is going to be -3/4 or -4/3, I wonder. And then this slope will be the opposite reciprocal. And then number 20, this is another circle. Aline, where would the center of that circle be? 2, -1, 2, 1, -2. What? Yes, it'd be -2, 1. 10. And we're going to do the same type of problem, just a little tougher. And so this is called the analytical geometry. Building the ideas of what we did all year, except connecting it to your algebra. And so your slopes and things like that you know. And so we're reviewing all that. And so we miss all you guys. Hopefully you enjoyed the video today. Email me. I look forward to getting to your homework. And remember, don't wait to send it in. You know, he who hesitates is lost, but a stitch in time saves 9. So make sure I get your homework and send it in right away, and email me your questions, or if I made a mistake on the video. Usually all my mistakes I make on the algebra videos. Too many little signs and things to keep track of. So hopefully we were good, but otherwise, let me know. Okay, bye-bye.